All right, so researchers watched groups of dolphins off the coast of Ireland in 1998 to determine what activities the dolphins partake in at certain times of the day. The numbers in this table represent the number of groups of dolphins that were partaking in an activity at certain times of the day. Is there enough evidence to show that activity and the time period are independent for dolphins? Okay, so what do we got here? So so when are they traveling, right? So they're traveling. Looks like they tend to travel a lot in the evening. When do they feed? Looks like they feed a lot in the morning and the evening. They don't feed in the afternoon. They socialize a lot in the morning, right? So clearly this appears to look like the time of day does have some effect on what sort of activity they're doing. Right? So, I mean, if we look at it this way, in the morning, well, it looks like they socialize a lot in the morning and they feed a lot in the morning, but they don't travel much. In the noontime, they're not very active. In the afternoon, they're also not very active. They're not doing much. But in the evening, they're active and they tend to be feeding a lot. So again, just looking at these in two different ways, we can see that it does look like the time of day has some effect on what activity they're partaking in. So the null hypothesis is that, which way did they word this? Activity and time period are independent. So the null hypothesis would be activity and time period are independent. And so that means that the time period doesn't have anything to do with what activity they're doing. And the alternative would be the activity and the time period are dependent. Okay, and so my gut says, yeah, it looks like they're going to be definitely dependent, but let's find out. We're going to do a chi-square test, right? So chi-square test is going to be what we observe minus what we expected to happen squared divided by what we expected, and we're going to add them all up. So we'll do the sum of all of these chi-square values. We've got all our data here in the table. So we're just going to go to the matrix. We're going to edit matrix A. I've got all the data there already entered. So this is a 3x4 matrix. So then we're just going to run the chi-square test. So we go stat, test, chi-square test. Now, I'm running the test, but I still haven't checked the assumptions. Remember, we have to have a simple random sample of the dolphins. And no more than 20% of our expected cell counts can be less than 5. Notice this 0 is problematic, and we've got some pretty small values in some of these cells. So I'm a little worried that maybe our sample size is a little too small. So let's go ahead and calculate it out. Let's not look at the results. I'm going to hide that. Let's go to matrix and let's look at the expected counts that it created for us. And we go, look at all of our expected counts. Okay, so there's 1, there's 2. All right, so 2 of these are smaller than 5. 1, 2, 3, there's 12. 1/5 of 12 is 2. All right, and so no more than 20% of our expected counts can be less than 5, and we have exactly 2, so it looks like we're okay. Our sample size is large enough. All right, so now let's go back to the test. And let's look and see what it tells us, chi-square. And our chi-square value is 68.4. The probability of that happening by random chance is tiny. It's essentially 0. Notice we have 6 degrees of freedom. Remember the number of rows minus 1 times the number of columns minus 1. So 3 minus 1, that's 2. Columns is 4 minus 1, that's 3. 2 times 3 is 6. That's where the 6 degrees of freedom come from. So what do we get? Our chi-square value with 6 degrees of freedom is equal to 68.4. The probability that our chi-square is as big as 68.4 or bigger is approximately 0. So therefore, we have strong evidence to reject the null. So the time of day, or we could say the activity, does depend on the time of day.